I mark attendance for okay. Okay, so I think got one or two more attendance. Yeah. Okay, general. Okay. Yeah. Okay. Anyone not getting mark attendance, you let me know in the chat box lah. Okay. Yeah. So. Okay. Okay. So now we see the chapter 1 now. Yeah. So just now we already done for the assessment topics and then software. Okay. We suppose start with the quiz 1. Yeah, quiz 1. Of course, can also outlook assignment anytime. Yeah. Yeah. So chapter 1 is only the introduction. Yeah, but actually it's still quite important. Okay, now you must understand your data first. Yeah, then only you know what method of data analysis is good for its appropriate. Yeah. Okay. So of course, multi means 2 and above. Okay, multivariate data analysis. Yeah. So. Okay. So these are the learning outcome. You see, it's more to methods and also the model building. How to build the model. Yeah, what method you're supposed to use depends on your data and also your objective. Okay. So these are the learning objective. You should be able to at the end of this chapter, you should be able to explain what method of data analysis is, means what is multivariate analysis. Also, when is application, is appropriate. Define and also discuss the specific technique that we are going to discuss, such as cluster analysis and also the discriminant analysis, and so on and so forth. Okay. So, meaning that this one also important. Meaning that when you see the research problem, or your research objective, you should be able to know what method of data analysis you should use. Okay. So example, So example, we come to the regression. Okay. Multiple linear regression. So most of you should learn this in the module you call statistics. Yeah. So when you see the term, the impact of the independent variable on the dependent variable. So you should use the multiple linear regression. Okay. Of course, we still have other conditions, but in general, this is the research objective that we should use. Yeah, if you're going to use the multiple linear regression. Okay. Or you can put it in another way. If you're going to achieve this objective, you should use multiple linear regression. Okay. So, okay. You see, this is very important. I know it's very basic, but it's very, very important. You should learn this already instead. The measurement scale. Means is nominal. Remember? Okay, nominal, and then scale, and then one more is ordinal. It's very basic, but it's very important for us. Okay, because a different scale, you should use different method of data analysis. Okay. So we see some conceptual and statistical issues, okay, that link to the multivariate analysis. Okay. So any question you can stop me and ask. Yeah. Okay. So far, okay. See, next one. Yeah. So now we continue. What is multivariate data analysis? Yeah, it's all statistical method that simultaneously analyze the multiple measurements. It means two and above. It means at least two variables. They're not univariate. Okay. Using univariate, we can do data analysis. Yeah, but not not multivariate. Yeah. Okay. So example, you can do ARIMA. You should learn this in time series and also forecasting. Yeah, we can do univariate, but this module is more to multivariate, two variables and above. Okay. So why you use this? Yeah, it's for measurement, and then we explain the phenomena and also do prediction. Okay. So we can do prediction. Of course, prediction is quite similar with the forecasting. Yeah, quite similar. Okay. But in this context, we should know this is a little bit different. Yeah, a little bit different between prediction and forecasting. Yeah. Okay. Okay. We see this now. Yeah. Okay. What is prediction? Yeah. So example, let's say you see okay, it's very basic economic theorem. Price. Yeah, price affect quantity. Okay. So now okay, this is a prediction. Okay. Forecasting. Yeah. So prediction, price and quantity. You collect, you do survey. You get 100 respondents. Yeah, n is equal to 100. It's a sample size. Okay. You give them different price and then see how much quantity they are going to purchase. Okay. So finally, you can come up with one equation. Example like this. Yeah, y equals to 2 minus 0.8 x. Okay. So x is the quantity, y is the price. Therefore, when sorry, I'm sorry. Okay. So price, the quantity. Yeah. Okay. You see, when the price increase, quantity purchase drop. Okay, based on the law of the demand, law of demand. Okay. So now, let's say you're given a price. Let's say now x is 0.5. No, let's say x is 1. Okay, 1. Yeah, okay. So y will be 2 minus 0.8, 1. Therefore, it's 1.2. So the person will purchase 1.2 unit. Okay, this is the prediction. Means you can predict the y using the x. Okay. Right. Now you see, for the forecasting, this must be, you must forecast for future. Example, even tomorrow, also future. You want to forecast let's say the forex, okay? The forex between US and also ringgit, US dollar and also ringgit Malaysia. So even tomorrow, but still consider forecasting. You can see there's a difference between a prediction and also the forecasting. Okay.
So, sir, prediction is we have a well-defined formula. For forecasting, something like extrapolating or
not like that. Not the well-defined formula, but actually this is not formula. Yeah. Okay. So prediction basically is for the regression. Okay, not regression. Yeah. So we can predict the y using the x, but because we can also find the formula or equation, yeah, for the forecasting. But forecasting must forecast for future. Can you see? Okay. But prediction is not. Prediction confirm not for future. Okay, this is different. Yeah.
So
because for forecasting, we can also find the well-defined formula. Example, ARIMA, kind of. ARIMA, you can find P, D, Q. Also defined, they were defined, but not, they were going to use this model to forecast for the future, but prediction is not. Yeah. Just that this is the prediction. We predict how much this person is going to purchase, given the X value, given the price of the product. Like that. Okay, hello. Yeah. Okay, the point is that forecast must focus for our future. And then forecast, you must use time series data. Okay, but you see, time series data, but now prediction is only for the cross-sectional. Okay, so forecast, you must use time series data. Okay, prediction you use. Okay, sorry.
It means the forecasting you need to have one variable should be have the time right.
Yes, correct. Example, the share price for past 1 year. The forex for past 1 year. Then you predict for tomorrow using the past data.
Okay.
But prediction, I can find these 100 people. I ask them how much they're going to purchase using this at this price level. I ask these 100 people on the same day. On the same day.
This is okay without the time. Don't need the time value. Okay, it's like
not say without time.
Okay.
Auto. Okay, done.
Yeah. Thank you.
Okay. So there's difference between forecasting and also the prediction. Okay. So we see, of course, testing of hypothesis, we are going to see this also, but the good news is that we are not going to do that much calculation. We see output. Okay. Yeah. Okay. We are going to more to see output and then do some testing of the hypothesis. Okay. So a quick review on the testing of hypothesis. In general, we need to form hypothesis studies. Example, beta equals to 0, beta is not equals to 0. And then we get output. From output, you can get p-value. Okay, you can get p-value. Example 0.0031. And let's say this is smaller than alpha, 0.055%. Whenever p-value smaller than alpha, we must actually reject the null hypothesis. Okay, so alpha is the significant level. Okay, so a quick review on what is the process of the testing of hypothesis. Okay. So we reject the null hypothesis. The hypothesis is not correct. Means you should use the alternative hypothesis to make a conclusion. Okay, this is hypothesis. Hypothesis can be used for many situations, not only for Z. You can do it for many things, many method of data analysis. Okay, so hopefully you still remember what you learned in STEP. But I'm sure not me. I did not teach this module for quite some time. Yeah. Okay. So can be. It's okay. Some of you maybe taught by Mr. Lau. Some maybe Mr. Miss Hazlina, some maybe Dr. Alex, and so on and so forth. Yeah, some teacher can teach this module. So, okay, any question on the idea of hypothesis testing? Wait, why? Okay, yeah, thank you. Okay, can I see? Therefore, it's correct because it's from the previous event, the previous, history. Because it's historical data. It forecast the future. Can I see? So you have to come up with a future event outcome, such as the forex in between dollar and ringgit. Now I think 4.4, is it 4.4 or 4.5? Like that. Okay. Okay. So without prior but not much. This is I think they did not use it much on from the statistical point of view. Not much. Okay, so we can use our discussion just now. Okay, to define the forecasting and also prediction. Yeah. Okay. Okay. Now we see next. Yeah. Okay. So okay, this one done. So means what is what we are going to do, yeah, for yeah, in this module. Yeah. Okay. So we see some basic concepts here of the multivariate analysis. Okay, the variate measurement scale. Importantly, you must know the difference, okay, between these two, because different measurement scale, we should use different method here of the data analysis. Okay, so you will see these few things in this chapter. Yeah. Okay. So variant is the linear combination. Yeah. Example, ax plus by is a simple example. Yeah, of the variant. Okay. We combine few variables. Okay, it become one. Example, here, the variate equation y hat y prime equals to w1 x1 plus w2 x2 and so on and so forth. W here refer to the weightage. Okay, so default in this context can be weightage, but in our case, multiple linear regression, the W can be also the beta coefficient. Okay, beta 1, beta 2, and so on and so forth. Okay. So and then of course we can estimate the value of the weightage. Before we can estimate it, we estimate it using the multiple linear regression. Okay. So each respondent has a varied value, because we can each respondent they are different value for the x1 example income. Different income, different education, different family size. We will get different value of the y prime. Okay. So here is more to still more to prediction. Means using different people's income, education, family size, we can predict. Example, maybe either having a house or not a house, like that. Okay. Either renting a house or owning a house. Okay. So we can predict the y. The y prime value is a linear combination of the entire set of the variables. Here got three variables. Yeah, x1. Well, here until xn, we can stop here until 3, w3. Okay, therefore only 3 independent variables. Okay, therefore the y hat, y prime is the dependent variable. x1, x2, x3 all independent. Okay, this is the example. Of course, we are going to see the next chapter will be the multiple linear regression. Okay, don't tell me you learned already in the statistics, because we are going to see much more. Yeah, so instead you learn quite basic. Okay, this is the basic, but of course we are going to see more detail here in this module. Okay. Okay. So if no question, now we see next. Yeah. Okay. So as I mentioned just now, this part is very important. Yeah. Okay. You understand first your data. Okay. The data can be non-metric, can be metric. Non-metric means qualitative. We can also call it categorical. Okay. So metric means quantitative, means number. I know you learned this already instead, but I must repeat here, because if you don't know this, then actually we cannot proceed with more advanced data analysis. Okay. Okay. So
Yeah, no problem. Yeah, can repeat.
Yeah,
No problem. You can repeat. I think I studied statistics quite many years ago. So
Okay, okay, yeah, thank you. So proceed, yeah.
Yeah.
Okay, so categorical is like, example, gender, male and female. Example, which country you are from? Of course, I know majority Malaysia. Yeah, some may not, some may be from Pakistan, maybe in this class. Okay, okay, some may be from Indonesia and so on and so forth. See which country you are from is category. Okay, categorical. Okay. So means the we can ask question, then the respondent will give answer. The answer is not in number, not in number. Okay. So okay. So these are the example, yeah, of the non-metric variable, non-metric data. Okay. So the metric, of course, example like your age. Okay. Example, how many module you are doing this semester? How many module you are going to do in this year? I know maximum 6. It can be 5, can be 4. Let's say you're busy, maybe only 5 or 4. You see, the answer must be number. Okay. So your result, maybe some are good, 3.8, some maybe not too good, 3.2, and so on and so forth. Number. Okay. The answer must be number. Right. So we see non-metric got 2. Nominal and also ordinal. Nominal, actually this example just now all nominal. Yeah. Miss what? Miss gender and also which country you are from. All nominal. Ordinal, actually ordinal, it's okay. I still can discuss, no problem. Yeah. Because the different not too important for us. It's okay, can discuss also. So example, let's say you watch a movie, you come back, you tell your friend that the movie, your friend asks you, how's the movie? You can say, your answer can be excellent. It can be very good, can be above average. It can be average, can be bad, and so on and so forth. But we know there's a ranking here. You see, there's a ranking, yeah, between among these comments. Excellent is better than very good better than good, and so on and so forth. Ordinary, ordinal come from the word order. You can order it from the very good from the top until the bottom. Okay, your best comment, excellent. Yeah, can be also very bad. Okay, so there's a difference between nominal and ordinal. Okay, so we done already for the non-metric. Okay, any question is?
Sorry, sir, just to understand, ordinal is the with the ranking. So
Yes,
the
correct.
excellent, very good. This is consider the ordinal.
It's correct.
Then the nominal one, sorry.
Nominal one, we cannot say which one is better. You can say
No
Indonesia
ranking.
better than Pakistan. You can say Indonesia better than Pakistan.
Okay.
Like that,
Okay.
okay.
Got
So,
it.
but
Thank you.
form is very clear. Excellent is better than very good better than above average.
Okay.
Okay.
Got it. Thank you.
Okay. So we see. Okay. Of course, quantitative both actually important for us. I mean, metric or non-metric. Yeah. Okay. So we see. Next. Yeah. Okay. Okay. One more thing interesting also. Especially if you're going to collect data later, yeah, or maybe in your capstone, or when you do some project, okay. Um, you can decide. Sometimes, not always. Sometimes, yeah, not always. Sometimes, yeah. Sometimes you can decide your data. You want your data to be metric or non-metric. Sometimes can, sometimes cannot. Okay. Example. Let's say education. Yeah. You can decide your data. You want to be your data to be metric or non-metric. Means you prepare the questionnaire. Maybe for your respondent or your customer to fill in. Okay. If you want non-metric, you can ask the education level. Example, up to high school. Okay, up to high school. Okay. And then you ask the respondent to fill in. Okay, and they want a preview. It means including diploma, foundation, yeah, and also certificate. Okay. And then maybe degree, yeah. And then okay, postgraduate and also professional. You can see. Using this questionnaire, you will get non-metric data. Okay, for the education level. Okay. But let's say you prefer to do, you want this variable to be metric. You can ask this question, your schooling year. Okay, schooling, schooling year. Okay, means until now, how many years you were in the school? Okay, so therefore, let's say for you, maybe, I mean for the general, okay, not always like this. For some of you, for most of you, okay, should be 6 years primary school, and then maybe 5 years until SPM in high school, and then maybe another 4 years in the uni, foundation plus 3 years degree, therefore 4 years. Okay, and then now maybe you are in second year, therefore you study already 1 year master. Therefore, you fill in 16. Can I say? Okay. So let's say those who only completed degree, no master, therefore fill in 15, like that. Okay. Therefore, sometimes you can determine what data you want. Okay. Meaning that you want metric, therefore you use this question there. This question in your questionnaire. No metric, therefore you use this question. Okay, therefore you can decide. Sometimes can, sometimes cannot. Okay. Okay. So if no question, now we see next. Yeah. Okay. So means you can decide, you can determine this by adjusting the question that you want to ask in the questionnaire. Of course, sometimes they take data from your customer. Let's say you do some project for a bank. If the bank gives you the data, before you can change. Okay, just follow. Yeah. So sometimes you can change, you can do like this. Sometimes cannot. So we see next. Yeah. Okay. So you see, metric means the answer, the value in the variable actually is a number, all number. And then be careful, the number is meaningful. The number is meaningful. Sometimes the number not meaningful. Example, okay. So some numbers actually are not meaningful. Yeah. Okay. Example, we see you see the flight number. Okay. The flight number. Let's say AK 039. Example. I don't know. Just simply say. Okay. You know. Okay. So 39 no meaning. This is a number. Okay. You cannot take 39 and then plus 2. Okay. 41. No meaning. Okay. Example, your IC number also meaningless. Of course, including your passport number, also no meaning. Okay, so maybe 8201 something, but here no meaning, meaningless. You cannot do calculation based on this number. Okay, yeah. Okay, so if no problem, now we see next. Okay. So now, of course, for us, we want some meaningful data, meaningful variable. Here for us to do some data analysis. Okay. So we see some metric quantitative got two, interval or ratio. Actually, these two consider one. They are under the SPSS. Okay. But we still can discuss the difference between these two, interval and also the ratio. Yeah. Okay. So actually, interval, we only can give two examples. Ratio, a lot. Okay. So interval, the first is temperature. Okay. Temperature, because the zero, no natural zero under the interval. Okay. So you see 0. What is the meaning of 0? 0 degrees Celsius. But ratio, this is the meaning of 0. Example, let's say 0 car. This I got no car. Okay. Example, okay. Someone maybe said that, okay, I got no degree. Before 0 degree. This completed high school. No degree. This 0 is natural. Yeah, that's the meaning of this 0. Okay. But this 0 is not natural. You can also use different meaning. You can also use, let's say, 10 degrees Celsius to represent certain level of the temperature. Because you use Celsius or use F, they carry different meaning. Can you see? Okay, 0 degrees Celsius is not equivalent to 0. What they call? F. It's different thing. Okay, so 0 is not natural.
So ratio is like something absolute.
It's correct. Absolutely 0 means nothing. 0 means nothing.
Interval is like relative, right?
You can say like this, yeah, meaning that the number still meaningful. Example, let's say we know 10 degrees Celsius compared to 23. This is much cooler. You can see it's much cooler compared to 23 degrees Celsius. The number still meaningful, but it's not that high level. Ratio is higher level. Okay.
Okay.
Okay. Okay. Any question? Yes. So you see one more example. One more example is the year. Yeah. Of course, we all know now 2022. Yeah, but 2000 years ago, this 1 year called year 0. Right not? Yeah, but this 0 is not natural also. This is because of the religion reason.
Yeah.
Okay.
Yeah. Different calendar also, different calendar. Yeah.
Yes, correct. Yeah, very good. Yeah, thank you. Different calendar also.
This one.
Okay. So you follow Western, therefore 0, now 2022. But even for different religion, different race, they got their own different calendar.
Yeah.
Okay. Therefore, this 0 is not natural. Okay, compared to ratio. Okay. So, but we seldom use interval. Therefore, not too important actually. We focus more on the ratio. Okay.
Okay.
Okay. Any question? Yes.
Sorry, sir. Can I ask you one question?
Yeah, sure.
Can I say numerical data is equivalent to this? I mean the quantitative data is equivalent to numerical data, and qualitative data is equivalent to categorical data.
Yeah. Okay.
Thank you, sir.
Okay, you can say like that. But again, the number, if number not necessarily metric, you want some meaningful data. You see, you want to some meaningful number. Yeah. So flat number no meaning. Your car plate also no meaning. Example, let's say A, yeah, 287. This one not meaningless. Okay. Okay. So we see here also got some, yeah. So okay. Actually, okay, it's okay. We done already, yeah, for the discussion. So okay, we actually done already, yeah. But importantly, can I see here ratio? Yeah, means the natural 0 point. The 0 is natural, yeah, under the metric, under the ratio. Okay, interval is different. Okay. So yeah, if no question, we see next. Yeah. Okay, so all variables have some error. What are the sources of the error? Okay. So first is the okay, we see the source of the error. So example sampling error. Okay, sampling error. So let's say you want to ask people something. Yeah. So people maybe don't want to tell you the truth. Example, this is survey from company. Yeah. Okay. Do you satisfied with your supervisor? Yeah. 1, 2, 3, or 5. Yeah. Do you satisfied with your supervisor? So here is strongly agree. Here strongly disagree. Yeah. Okay. So maybe the person don't like supervisor, but just fill in 4. That is, it's possible in your life. Okay. So therefore, sampling error can come from this case. Okay. Okay. This is one of the example. Okay. So another example can be the different accounting issue. Yeah. So let's say country A, country B. Yeah, they measure the accounting. Maybe some accountant here, but it's okay. I can still discuss. No problem. Okay. So we know also the depreciation, right? Yeah. So depreciation of the asset can be different, yeah, in different country, even two different company. Okay, so because different method used, therefore this will affect the profit. Can I say therefore? Maybe you can compare the profit here from company A and company B. Yeah. Okay. So this one may happen. Yeah, we call this measurement error. Okay. Okay. So therefore, this may distort the observed relationship, okay, and also make the multivariate techniques less powerful. So because data is not too good, therefore the result also not too good. Okay, we see you should know this for some IT student. Okay, we see. Okay. It's very simple model. Okay, I'm sure IT student know. Yeah. Yes, correct. Okay. So can you see? Yeah. So you input, you process it, you get output. Let's say input not good. Let's say in factory, the raw material not good. Yeah, the output confirm cannot be good. Okay, for us, same thing. Input is our data. If data not too accurate, you process it, means you do data analysis using software. So output cannot be so good. Okay, same thing. Okay. Therefore, you must handle you must make sure that the measurement error data is as accurate as possible. Okay. Of course, let's say data from your customer, the Maybank give you the data, you have to do data analysis. They point you as a data scientist to do some project. Okay, you cannot control the data. Okay, just use. Okay. So, and also because of this, therefore we never say 100% confident, 100% confirm. We reject the null hypothesis. We never say like this. Okay. So we may reject the null hypothesis, but only if 35% you're confident like that. You're not 100%. Because we know the error are always there. Right? But this state, we try to minimize the error. We try to make sure that data is as accurate as possible. So that's what we can do. Okay? But we never say 100% accurate, 100% confirm. Never. Okay. If no question, now we continue. Any more attendance, you can let me know. Anyone join a bit late, you let me know. Yeah. If not, we continue. Okay, with the discussion. Okay. So therefore, the error will distort the observed relationship. Okay, it also make the technique less powerful. Okay. So we can use some method. Okay, some method. Researchers use some method skill. Okay, for which several variables are summed or averaged together to form a composite representation of a concept. Okay, so this one can be used to reduce the error. Okay, see how we do this. Yeah. So let's say you want to measure you want to measure the commitment, okay? Commitment of your employee, yeah, okay. So we normally ask more questions, not only one, but more questions, but to measure only one thing, which is commitment of your employee. Okay. So example, okay. Example, let's say okay, you see you ask this question. Check email even weekend. Okay, even weekend. Okay. So like this. You ask one question, maybe cannot be good to measure commitment of your employee. You can ask more questions. You see? Okay. Okay. Including example, try to improve. Try to improve the quality of the work every month. Okay, and so on and so forth. So you ask 5 questions. Okay. Again, we can use the Likert scale 1, 2, 3, 4, 5. 5 is this is strongly agree. Yeah, 1 means strongly disagree. Okay. Let's say this one employee answer here, yeah, 4, 4, 4, 4, and then let's say here 2. So therefore, you sum together. You sum together these few numbers before you get 18. Means you use 18, you key in 18 in the software. You have to do data analysis. Okay. Therefore, we call this method. We call this segmented scale. You see, several variables. Here got 5. You ask 5 questions in the questionnaire. But then finally, you sum up together. You sum together, okay? Or maybe you can also take average. Average means 18 over 5. Okay, so 18 over 5, you get 3.9. Okay. Oh no, sorry, 3.6. 3.6. Okay, so you get 3.6. So means you key in 3.6 in the software to do data analysis. Okay, so by using so, you can actually reduce the problem of the measurement error. You see? Okay. So because if you take only one number, only one question, if you ask number 5, therefore it's wrong, even too much. 2 and 3.6. But take 5 questions, on average 3.6, still quite close to 4. Means this employee still considered quite good, but only one question, one part are not too good. It shows that are not too committed, but actually still consider okay, because majority answer 4. Okay, so we can reduce the measurement error by asking more questions, and then we find the average. Okay, yeah. So to form a composite representation of a concept, here we call it commitment of the employee. Okay. Okay. Because commitment is really difficult for us to measure. It's not something you can see. Okay. So we can use some question here to measure the commitment of your employee. Okay. Any question? Yes.
So, sir, how to decide which numbers can be submitted?
What do you mean by which number can be submitted? The
Let's say,
meaningful number all can be submitted. Yeah.
I mean, they should have similar properties or characteristics, so you can submit them together, something like that.
Okay. You are right. So they supposed to have similar characteristics. Means all actually is to be used to measure the commitment. Yeah. Okay. Yeah. Good question. Okay. And then one more thing, they must have all same direction. Yeah. Example. Yeah. Example. Check email even weekend. Yeah. If do so means committed. Therefore, if let's say answer 4 and 5 means committed. Let's say always think about how to improve the work quality. If yes, means also good 4 and 5 like that. Okay.
Okay.
Yeah.
Understood.
So yeah.
Thank you.
So means what? Means therefore answer 4 and 5 always would always consider committed, move the same direction. Okay. Yeah. Okay. Okay. If no question, now we see next.
Oh, sorry, sir. Can I ask you about this? For example, the commitments. Let's say we have 5 questions, and these 5 questions mainly measure the commitment of the students. So there could be have some properties or characteristics is related to commitment. So is there any way for us to check whether is this group of questions are related to commitment in statistics? Is there any calculations that we can check? For example, look at the chart or something like that.
Okay, good, very good question. Very good. Okay. So actually, you want to make sure that the question are good. Got two things you need to do. First thing is the validity. Yeah. Okay. Yeah. This basically is to request some expert to make sure that the question actually is meant to measure the commitment. Because commitment and motivation sometimes looks like quite similar. Commitment, motivation looks like quite similar. Okay, therefore, you can refer to some study or request some expert to help you to make sure that the question are meant to measure the commitment. Okay. Come back to the question, how to use some, a very good question. Yeah, okay. How to use some statistical tool to measure actually the term that we use is, we call it reliability. Yeah. Okay. 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 So the term that we use is reliability, means to make sure that your respondent can understand like what your idea, your meaning. Okay. So means your language that you use actually is accurate. Your respondent understand it. Therefore, the question will be reliable. You see, some question is very bad. Example. Yeah. Where are you? Where are you come from? You see, this question is very bad. When you're meeting a new friend, you ask this question, you may get at least different kind of answer. Some may answer, I'm from Malaysia. Some answer, I'm from Citibank. You see, it's not very clear. This question is not good. Okay, you may ask, okay, which country are you from? Okay, therefore, straightforward, clear, accurate. Okay. So sometimes this one may happen also when come to the questionnaire. Before you must check the reliability. Okay. So reliability using Chromebook alpha. Chromebook alpha. Actually a lot. This is it's not the best. I cannot say it's the best. I can say it's the most popular tool that we use to check the reliability. Okay. Yeah. Okay. So this is the measurement error. Okay. Any question so far? Okay. So, okay. Okay, if no problem, now we see next. Yeah. So now, yeah, actually discussed already just now. Okay, it's okay. So, before you are too advanced, it's okay, no problem. Okay. So in addressing the measurement error, researchers evaluate two important characteristics of the measurement. Okay. So validity, the degree to which a measure accurately represents what it is supposed to. Okay. So means the question that you use, how sure are you they can measure the idea of the commitment? Okay. Okay. So as I mentioned just now, you can request some expert to check for you. Also some refer to some journal, some study. Okay. So reliability also discussed already. Yeah. Okay. So we have another term. Yeah, that for the reliability, we call this internal. Okay. Internal consistency. Okay. So to make sure that they all measure the same thing, yeah, internal. So, okay, a little bit more for the Chromebook alpha. They will give us some number from the output. So 0 is minimum, 1 is the largest. In general, close to 1 means good lah. Okay, close to 1 means good. Okay. And we do this before. Before you send out the questionnaire to the respondent. This one is after. Okay. Once you got data, you can actually do some data analysis. Yeah, to make sure that the respondent actually really understand your idea. Okay.
So can I say that the validity test is during the pilot test and reliability is after we already get a pilot test and then check the validity, then we only start to do the reliability test?
No. Reliability means once you got the data.
Okay.
The respondent already fill in the data. You already got the complete data.
Okay. So meaning if my Chromebook alpha is less than 0.5 or 0.2, can I eliminate that variables from my measurements?
Good question. This is not statistical issue. It's more to a research issue. So, but still can discuss. Okay, still can discuss. Yeah. So, let's say you have let's say you got made five questions to measure one dimension, your commitment. Therefore, if you feel that one of them not so good, you can delete. You can remove the variable. Okay. Yeah. Okay. But actually, you suppose can identify it during the pilot test. Yeah, see? Yeah, this. Okay. So, okay, you should know. Okay, pilot test. Okay. So, you do pilot test. From the time let's say you just survey 20 people. You suppose know already which question are not too good. Respondent not actually understand your idea. Like that. Okay. But in case still happen, let's say the alpha is too low, 0.2, you can try to remove one variable, then you test again, you see how. Okay. Okay, so if no problem, now we see next. Yeah. Okay. Okay. So this is very statistics. Okay. Okay. So we see the statistical significance and power. Okay. So therefore, you see in the module called stat, you only learn significance, but you never learn power. Okay, we see all now. All right. So you see this table now. Okay. So this is the decision of the researcher or data scientist. Okay. This is the state of the nature. Okay. State of the nature. Okay. So meaning that we have the null hypothesis can be true, can be false, but we don't know. You see, we don't know. We can only make decision using sample. But the state of the nature is the population. Example, you get a sample, yeah, 1,000. But the population maybe 20 million people. Okay, therefore, you use the sample, but you want to make a conclusion about the population. Therefore, the decision actually subject to error. Okay. Of course, what we do, we can try to get a good sample that can represent the whole population. That's what we can do. We can try our best, yeah, to do that. Okay. But we still subject to to some error. Okay. You see, decision can be failed. Means cannot reject the null hypothesis or reject the null hypothesis. Okay. And then state of nature, the null true, null is false. Okay. Now we see the best situation. The best is that we cannot reject the null hypothesis, but the null is true. Therefore, no problem. no problem. Okay. And then another one also good is 1 minus alpha, 1 minus beta. Okay. So the alpha and beta actually is a number in between 0 to 1. Okay. So let's say the power is 1 minus beta. This we can reject the null hypothesis. And the null is false. Therefore, it's good. Okay. Means we say something, we rejected the null hypothesis, and then the null is false. Means something good lah. It's something good. Okay. Example. Yeah. Okay. So example, let's say y equals to 0.2 and then plus 0.8 x. Okay. So we know this is come from the simple linear regression. Yeah, alpha plus beta x. Try to recall back what you learned in statistics. Okay. Therefore, the hypothesis looks like this. Beta is 0 and beta is not 0. Okay. Any question so far? Maybe I ask you a question. Yeah. Why the hypothesis looks like this? Why? Okay. No what? Okay. If no answer, I tell you the answer. Don't worry. Okay. For not being too optimistic, no. No. It's okay. So,
Is it there's no relationship?
okay, this answer I can give you 8 points out of 10. Okay. Okay. So it's good. Yeah, your answer is almost correct. Okay. So actually like this. You see, in beta 0, yeah. Therefore we get therefore if beta is 0, therefore we get y equals to alpha plus beta plus 0 x. Therefore y equals to alpha. Because 0 times x is 0. Okay. Okay. So therefore, the x is no more in the equation. And recall back, regression is how we measure how we actually want to examine the impact of the independent variable on the dependent variable. If now this term disappear, meaning that x cannot affect the y. Okay, x cannot affect y. Why I say you score 8 of 10? Because we actually doing the regression. Therefore, it's basically it's on the what? The impact of the x on the y. Can you see? Okay, the impact of the x on the y is cause effect. Not only relationship, but it's the impact of x on the y. Okay, so relationship is correct. Relationship is it's correct but general. Okay, it's more accurate. Should be this the impact of the independent variable on the dependent variable. Okay. So now the x disappear. Therefore, beta is 0. Means here. Meaning that we cannot reject the null hypothesis. Okay. But now, if you rejected the null hypothesis, therefore it's good. Yeah, we rejected the null hypothesis. Yeah, therefore beta is not 0. Example 0.8, 0.8x. Beta supposed to stay in the equation, and therefore x also should stay in the equation. Therefore, the X can affect the Y, because this term is important here in the equation. Okay, therefore, we reject null hypothesis is good for us in general. Okay, in general. Okay. So sometimes we prefer to not to reject null hypothesis. Not say, of course, we cannot change data, but sometimes we may see we cannot reject null hypothesis. We are happy. Okay, sometimes I will show you in this chapter later. I think no, maybe next chapter. I think next chapter. Okay. Okay. Yeah, so can even also same thing. We assume there's no relationship. It's not relationship, it's the effect of the X on the Y. Yeah. Okay. But you got the idea, okay, you got the idea. Okay, I can give you 9 marks, yeah, for this answer. It's a bit better. Yeah. Okay. The slope 0, meaning that the X cannot affect the Y. Okay, in this context. Yeah. Okay, if no question, now we see next. Yeah. So therefore, for this context, yeah, if we can reject the null hypothesis, means we are very happy. Yeah, because if we reject the null hypothesis and then the null is false, means we are good lah, we are happy. So this is 1 minus beta. Okay, we call it power. Okay. So power higher is better. Later we will see the optimum point should be 0.8. Okay, 0.8 means it's good lah. Cannot be too high. Yeah. So 0.8 consider is the best. Okay. Any question is so far? Okay, if no, now we see next. Yeah. Okay. Okay. So now we see just now the 1 minus alpha, 1 minus beta all consider good, but sometimes the outcome may not be good. Example, yeah, we rejected the null hypothesis, but the null is true. Means you make a mistake. You can see, you rejected the null hypothesis, but the null is true. Okay, therefore you make a mistake. So we call this error. Therefore, this is error. Okay, alpha is error. It's type 1 error. Okay, so we call it also significant level. Same thing, same thing. Okay, so alpha is the type 1 error. Okay, okay. So you should learn this also. Alpha can be 1%, can be 5%. It can be also 10%. Okay. If no question, type 1 error is much more important compared to beta. Yeah. Type 2 error also not good, but not too serious compared to type 1 error. If we focus more on the type 1 error in many textbooks like that. Okay. So type 2 error means we cannot reject the null hypothesis, but the null is false. You can see something wrong, but you cannot say it's wrong. Something wrong, but you cannot prove that it is wrong. And therefore also not good. Yeah, but not too bad compared to alpha. Okay, therefore you focus on alpha. Okay. Okay. If no question, sure. Okay. If no question, now we see next. Yep. Therefore, this is the official definition. Yeah, for the type 1 error. Again, type 1 error is also significant level. Right. So alpha is the probability that we reject the null hypothesis, but the null is true. Okay, therefore, it's also an error. Type 2 error, we cannot reject the null hypothesis, but the null is false. Right. So, okay. So power is 1 minus beta. Yeah, it's the probability of rejecting the null hypothesis when it's false. Yeah. So the higher is the better. Because the null is false, but we can reject it. Therefore, it's good lah. Can say it's something very very good. The null is something wrong, and you have evidence to say it's wrong. Therefore, it's good. Okay. Okay. Any questions, please? Okay. If no, now we see the 3 factors that can be used to affect the power. Okay. So the effect size. Okay, the effect size. We see this now. Okay. The effect size. Therefore, still hope that you can still remember what you learned in statistics. Okay, we see the effect size. Example. Okay. Okay. Example, let's say mu is equals to 3. Yeah, and then mu is not equals to 3. This is the one sample t-test. You should learn this in statistics. Okay. Remember, mu is the population mean. Yeah, population mean, and we can compute the x bar from the sample. Let's say sample is 500. X bar, let's say, is equals to 6.2. Another one, x bar equals to 3.5. Yeah, same sample size. Therefore, for let's say this is case 1. Yeah, case 1 and then case 2. Let's say first sample, and then second sample. Therefore, the second sample have higher effect size. Okay. So because the difference is a lot, 3 you minus 6.2, difference is a lot. Different a lot, higher chance for us to reject the null hypothesis. Okay, again, if the difference is a lot, therefore easier for us to reject the null hypothesis. If difference is small, the case 1, it's difficult for us to reject the null hypothesis. Okay, don't worry. It's very simple thing. Give you formula. Yeah. Okay. Yeah, Z. Okay. X bar minus the mu. Yeah, sigma over square root of n. Maybe a bit technical, but I feel that give you formula should be easier to understand, hopefully. Okay. So remember, this is the formula for us. You have to compute the test statistics. Test statistics for the Z. X bar minus mu over sigma over square root of n. Some of you should learn this before, especially if your degree is from business or economic or accounting. You should learn this before. Yeah, okay. So we call this critical value approach. X bar minus mu over sigma over square root of n means over this term. This term assume it's the same between this case 1 and case 2. Therefore, the difference is only the x bar. For the case 2, x bar is 6.2. 6.2 minus 3, we get 3.2. Can I see? Okay. But for the case 1, we get 0.5 over sigma over square root of n. That's for the case 1. Okay, so this is for the case 1. Therefore, we know the case 1, the value must be smaller compared to case 1, case 2. You see, the case 1, this value, this is the test statistics. For the case 1, must be smaller compared to case 2. Because 3.2 over a number, a same number. Again, we assume this number is the same. Okay, same number. Okay, we use a number, no problem. Let's say 0.5 over 0.5. Here, 3.2 over 0.5. Here, we get 1. Okay, here, we get 6.4. Okay, for case 1, you get 1. Case 2, you get 6.4. 6.4 is the test statistics for the Z. Remember, Z is the normal distribution. Z is the standardized normal distribution. Okay, so you get 6.4 for case 2. And remember also, when the test statistics is larger, it's easier for us to reject the null hypothesis. It's okay. Hopefully, I can use this diagram to recall for make you to recall back what you learned in your degree. Okay. So let's say here is 1.96. Okay, now 0 Z. Okay. Yeah. 1.96 is critical value. Okay. Therefore, this method we call it critical value approach. You can see CB, the critical value approach. Okay. So when now for the case, okay, remember what we call this region? We call this rejection region. Okay. Okay, don't worry. Okay, rejection. Okay, rejection region is this shaded area, a small area. Okay. So if the test statistics is fall into this area, means we can reject the null hypothesis. So for us, the case 2, we get 6.4. Therefore, we can reject the null hypothesis under the case 2. Case 2, 6.4 is correct. Okay, 6.4. Therefore, we reject the null hypothesis under the case 2. But for the case 1, we get only 1. Okay, so it means we compare the critical value with the test statistics. So test statistics is 1 here for the case 1. Therefore, for the case 1, we cannot reject the null hypothesis. Okay. So therefore, we see for the case 1, the effect size is small because we take 3.5. Yeah, 3.5 minus 3, you get 0.5. The effect size is small for case 1. Therefore, we cannot reject the null hypothesis. But the effect size for the case 2 is larger because you take 6.2 minus 3, we get 3.2. The effect size for the case 2 is much larger compared to case 1. Therefore, we can reject the null hypothesis, yeah, for the case 2. Therefore, this is the conclusion. You can see. Okay, so 3.5 minus 3 get 0.5 is small. Okay, and then 6.2. Why not? Yeah, correct. 6.2. Yeah. So 6/2 minus 3 is we get 3/2 is large value. Yeah, therefore the effect size larger is easy for us to reject the null hypothesis. This is just an example. We can also apply this idea in other method in the correlation. Also can. Yeah. Okay. Okay. So the example that I'm using is the difference between the means. You can see, meaning that the x bar minus mu different a bit or a lot. If different a lot, easier for us to reject the null hypothesis. Okay. So this is the effect size. Okay. Any question is? Okay. Anyone talking about attendance? Yes, 30-something student, but we need to have three intakes. They make it 3 intakes. Okay. It's okay. I call your name now. Jin Long Yu, are you here? No. Oh, sorry. Here's 0. Yeah. Here 100%. Okay. One more. Okay, here one student. Okay. Zhong Mu Ying, are you here? Nothing. Okay. Okay. So any question for today? Means we discuss the what?
So the effect size is just we use the Z score to decide that, right? The critical value and the Z score.
It's correct. The Z score that you mentioned is the test statistics. Is correct. Okay. But effect size is more general. Okay, give you one more example. Okay. Okay. Effect size. We discussed one example just now. We take x bar minus mu. Okay. You can also use the. You're right. You can also use the test statistics. Yeah. Minus the critical value. Okay. Another one, you can also compare the correlation. You see? Okay. Therefore, effect size is more general. Example, let's say you got two cases. Yeah. Okay. Case one, it's okay. It's case A and case B. So for case A, the correlation is 0.72. The case two, the correlation is equal to 0.12. The case A is easier to reject the null hypothesis. You see? Therefore, this one is also effect size. You take this number, you minus 0. You see, difference is higher compared to this. Therefore, case A is easier for us to reject the null hypothesis. Okay. Yeah. Therefore, the power is higher in case A compared to case B. Okay. Okay, so if no question, means now today we finish the introduction, discuss a bit the assessment, the planning, quiz 1, quiz 2, test, assignment. Okay. And then also discuss the chapter 1 until the 3 factor. Of course, the factor 2 and 3 will be tomorrow. Okay. So for the tomorrow, we just follow the what they call? You follow the schedule. Okay, for the break time. Okay.
Tomorrow 2 o'clock, right? 2 p.m.
Yeah, it's correct. 2 p.m. Yeah, correct. 2 p.m. 2 until 7. Yeah, tomorrow. Okay. Okay. So this for today. Any questions?
There are some people not yet signed in. Sin Chong Seng.
Wait. Any question you can ask now? I think already signed in, is it? Hello?
No, sir. I think the admin has missed out my enrollment, so I will need to check. Yeah, I need to check whether I will need to check with admin about this.
Oh, okay. Okay.
Thank you.
Okay, means your name is in the Moodle but not in the attendance list.
I'm not quite sure. Let me take a look.
Suppose because your name supposed in the Moodle, in the Moodle. Okay, we can check now. It's easy because I add your name using the list from the Moodle. Okay, we see now. Yeah. Okay. Okay. S, you need to start from S.
S, yes, correct.
Not here. Oh. Okay, how you join the team using the link?
No, I got the invite. I got the code, and so I straight away joined using the code.
Okay. So basically, you check with the admin, so that the admin can put your name in the Moodle. Okay.
Sure. Thank you.
Okay. Okay. So if no problem, so see you tomorrow at 2 o'clock. Yeah. So thank you. And see you.
See you, sir. Thank you.
Thank you.